Hi guys, how are you doing? Hopefully things are going well on your first day through e-learning. What we're going to today, again, that assignment is going to be due Friday by 11:59. Some of you guys have already been turning it in, but every day I'm going over a little piece of it. So today we're going to do problems like 10 and 11 where the bases cancel, and then very basic solving. Tomorrow we'll do more complex solving where we're condensing and then solving from there. Okay? Hope you guys are all doing well. We are going to switch to Zoom instead of Google Meet from here on out for class meetings. Your class meeting time is from 9 to 9:20. I sent you an email through Schoology about how to do Zoom. You will have to download the Zoom app. It's user-friendly on a Chromebook, a PC, or a phone, and you can join anyway. I saw some of you guys today. I hope to see more of you guys tomorrow. So let's talk about solving logs and exponentials and kind of what happens with bases canceling. So let's talk about those quickly today. So, for instance, again, here's all the review. You just kind of remember from yesterday, we kind of went through these. Log form is log base e of x equals y. Exponential form is b to the y equals x. So that's how you change back and forth between forms. And just to recall here, that natural log is the same thing as log base e. We'll have to use that a little more tomorrow when we start solving a little more complex problems, but I'll make sure to cover that tomorrow. Also, to remember, we'll be using much of this today. We'll be doing more tomorrow when we start solving. But that addition means multiplication. This is expanding. That's condensing. Subtraction means division. Expanding, condensing. And then when you take a power to a power, that's like multiplication. So just like those exponent rules that we talked about. So let's get into the lesson for today. So for instance, if I have e to the log base e equals 12, if the exponent base and the base of the log are the same, those are going to cancel out, and we're going to get to just 12. So 12 would be my answer there. Okay? Same thing here. Log base 8 to the 8 to the 4x, the base of the exponential and the base of the log are the exact same. So those are going to cancel, and I'm left with 4x. Okay? So I believe those are 10 and 11 on your worksheet. But those is how they cancel. If the bases aren't the same and they can't cancel, you have to set them equal to y and then solve from there. But all the ones on the worksheet, they should cancel out just like that. Okay? Next problems we're going to do are just solve simple equation ones that are very similar to the ones on your worksheet. Okay, again, we're just reviewing from what we did beforehand, not too much for this week, and then we'll start new stuff next week. So let's say I have log base 2 of 4x equals log base 2 of 12. Because these bases are the same and it's a one-to-one cancelization, there were two logs over here. I couldn't cancel all of them. I had to condense first. What I can do here is that these logs cancel and go away. So what I'm left with is 4x equals 12. And then from here, we just divide both sides by 4. Those would cancel and I end up with x equals 3. Now you want to make sure you check your answer that when you plug in, those do work because there is such thing as extraneous solutions. So when I plug in here, 4 times 3 is 12. So we get log base 2 of 12 equals log base 2 of 12, which works. So I know that x equals 3, so I'm done with that one. Okay, so that's what you would happen if they were the same logs on either side, or if they were the same base exponentials on the same side, those bases would cancel. We did a problem similar to that yesterday. We had to manipulate both bases. And that's also what we're going to do on this next problem. So this next problem is similar to ones you'll see on your review. It's 100 to the 3x minus 1 equals 1/10 to the x plus 2. Well, right away, these can't cancel because they're not the same. So we have to manipulate the numbers to be the same. So I know 100 is the same thing as 10 squared. And I know that 1/10 is the same thing as 10 to the negative 1. The negative exponent causes it to drop below. So I'm just going to manipulate those numbers, and I'm going to change them to get 10 squared and then 3x minus 1 equals 10 to the negative 1 x plus 2. So if you notice here, it's squared. 10 squared is the same thing as 100. And I put that 2 in front of that parentheses. I am going to distribute it through. And then I change that 1/10 to the 10 to the negative 1. Again, I'm going to distribute it through as well to the exponents. But because these are both 10s, I'm allowed to cancel them out, okay? So then I'm just left with what's in the exponents. So when I get that, I'm left with 2x, 2 times 3 is 6. I'm left with 6x minus 2 equals negative 1x minus 2. So I'm left with 6x minus 2 equals negative 1x minus 2. So then from there, what I'm going to do is I'm going to solve it. So I'm going to add 1x to this side, and I'm going to add 2. I'm going to add 1x over here and add 2. Those are going to cancel, so I'm left with 7x equals 0. And a common mistake here is that people are going to say, oh, the answer is undefined, I can't do it. No, I can solve that, okay? So I divide by 7, and I end up with x equals 0. Only when the 0 is on the denominator is it undefined. When the 0 is on the numerator, it's just 0. But I have to check to make sure I'm right, because 0 seems like a weird answer, and I want to make sure it works. So when I look at this problem here, if I plug in 0 here, I get 3 times 0 is 0. So I get 100 to the negative 1. And I get 0 plus 2 is 2. So I get 1/10 to the negative 1, which would both give me 1 over 100. Okay, so it does work, so x equals 0. Okay, so we did the one where the log bases were the same and they cancel, one where we manipulate the number and the exponent bases are the same and they can cancel and we just solve. And the last one we're going to do, and probably the hardest one, is what do we do in this situation? When I get log base 4, 3x plus 2 equals 2. Bases can't cancel here because there's not the same thing. There's only one log here and one the other way. So I can't cancel anything to make my life easier or manipulate the numbers to make my life easier. What I have to do is I need to change the form. So right now we're in log form. Log b to the x equals y. And I'm going to change it to exponential form. B y to the equals x. So when I do that, I get 4 squared equals 3x plus 2. Well, this looks like a lot easier problem to me that I can solve. There's no logs, there's just numbers there, and I'm good to go. So I know that 14 is the same thing as, or 4 squared is the same thing as 16, equals 3x plus 2. I'm going to subtract 2, and I get 14 equals 3x. Divide by 3, and I'm going to flip this x equals 14 thirds. And when I plug that back in, it does work. Okay, because I end up with 14 plus 2 is 16. When I change forms, 4 squared equals 16, so we're good. Okay, so my answer is x equals 14 thirds. I know there's a problem on the review that you're doing that you have a fractional answer, but it's okay to get fractions. You don't necessarily have to have whole numbers. Again, you're going to, when you're ready, again, it's not due till Friday night, you're going to submit the review. I'll see it, I'll look over it, make any comments that I need to, and send it back to you. And then on Saturday morning, I'll post the answer key to the review with my work shown. So if you did get something incorrect and you need more clarification, you also have that as a reference, okay? Well, it was really good talking to you guys. I hope you guys have a great day. Enjoy the beautiful weather outside, and I will see you tomorrow on Zoom. Can't wait to see you guys. Have a great day. Thanks for coming. Bye, guys.